Okay, I am going to add to Parth's explanation here about your normal distribution and how you can use Excel to find the probability of the left side of a particular value. So the example I have, they're actually calculating the z-score and then putting the z-score into Excel, or you can skip that and go straight to Excel and put in the mean, standard deviation, and X. Either way, you're going to get the value of the left side of the curve. So the value of the side that is white is what you're going to get, that area. If you want the side that's greater than, if we want to find the probability that it is greater than 370, that X is greater than 370, we would have to use the complement rule. And what that says is the white side plus the green side, the total area under the curve is equal to 1. So if I want the greater than side, I get the probability of the left side, the white side. I will say 1 minus what I get for that probability. So I wanted to show you that real quick. And I'm going to show you either way. So if you did equal norm dot dist and you put in X, which is 370, you put in the mean, which is 350, and you put in the standard deviation, which is 55, and then you want to put in true, because I want to get everything up to this point, everything in white, the less than side. So the probability of it being less than 370 is 0.641935. Now the other option is you could calculate the z-score, and if you do it that way, you're going to select norm.s.dist, and then you're going to put the z-score in, which is 0.3636, and I believe it keeps repeating, and then you put true. You're going to get about the same number. It may be rounded a little bit. Okay, so the number up here is going to be more of an accurate number since we did round the z-score. But if you rounded to 4 decimal places, 6419, 6.6419, you're going to get the same answer. So if we want the greater than side, we would use the complement rule. We know this whole area under the curve is 1. If I subtract out the area that I don't want, which is the less than side, 0.6419, then that will give me the probability of the greater than side, which is 0.3581. But if you change that to a percent, and you want it to include the decimal, 35.81%. Or if you want 1 decimal, 35.8%. So that is how you work these type of problems and how you use the complement rule to find the greater than side.